Okay, so it's nice to connect with you. And now, without taking your more time, let me start the session directly without any more delay. So, first of all, let me tell you about the workshop that we are joined tonight. So, this will be your live workshop, and I will be your trainer for this workshop. This workshop is conducted by ELP, Electrical Learning Portal. Electrical Learning Portal is an online institute which is working continuously since lockdown period of 2020. So now this is the topic of your workshop, which is LV Electrical System Design. So uh, we are coming to understand the word from basic. What is the meaning of LV in just two lines? What is the meaning of LV? Because all you are engineers, so I will not spare more time on these words like what is LV electrical, as you already know. Now coming to the first point that my name is Sadiq Hussain and I am electrical engineer. I am having about around 10 years of experience in electrical in industry. So I'm having experience of designing. I'm having experience of execution also. So this is my LinkedIn profile. You can also connect with me on my LinkedIn profile. So now coming to the point, what is the meaning of electrical? What is the meaning of designing and drafting? Most people are confused with these two names. So, what is the meaning of designing and drafting? Sometime, many times, what people think designing means creating drawings or layouts, but actually that is not. So, first, let me tell you about this. This is the course or workshop is only for LV. LV stands for low voltage. Low voltage as per IEEE. As per IEEE, we are classifying the complete electrical system into two classes. One is LV and one is HV. LV system will be the system where operating voltage will be less than or equals to 1000 volts or 1 kV. Whereas the HV system will be the system where operating voltage will be or nominal voltage, you can also call it as where the nominal voltage will be greater than 1 kV. Okay, in this HV, we there will also be your MV, extra high voltage, ultra high voltage, everything. But as per the IEEE classification, we have two classification, LV and HV, or sometime you will find in some journals it like LT and HT, high tension and low tension. So this is the meaning in this workshop or in this course we will discuss only the system where the nominal voltage will be less than 1000 volts. Okay, now coming to the word electrical. Electrical is a field of engineering which deals with electricity or which deals with current and voltages. Now coming to the designing. Designing is not a mean to create layout or drawings. Actually, designing is a mean to select correct and appropriate equipment of your system, and not only selecting, but after selecting correct and appropriate size of your equipment, then arrange them in a proper manner. This is the main designing. In coming slides, we will discuss some more in detail about what our responsibilities as a design engineer. We are not just a calculator, just make some calculations plus minus and tell the size of the equipment. This is not, and actually, this is not the scope or the main responsibility of designer. I'm coming on that after this. So the designing is the name of select or choose the correct and appropriate equipment and arrange them in a proper manner. This is the thing. Then after this drafting, the drafting is the name of creating technical drawings. Like you also already know that SLD. SLD is a drawing or blueprint of the complete power system, where the complete power system will be shown or created by using some symbols and one one line or single line which represents your feeder, whether it is your cable or bus bar. So it will be your single line which represents your feeder, and other equipment will also be created or shown by some symbols. Okay, so drafting is the name of creating technical drawings, so SLD, lighting layout, power layout, conduit layout, every layout, cable layout, cable tray layout, cable routing layout, trench layout, all these drawings or layouts are uh, they come under this drafting. Okay, generally we create in early days we create or our engineers create drawings by manual method, by creating drawings by using some pencils and papers. But nowadays we are creating technical drawings, or we are doing drafting using some CAD software. Mostly people use for 2D drafting AutoCAD. So these are the different words that we should know before starting, and this should be clear in every mind what we are going to learn in this workshop. LV we'll discuss only for LV system and electrical designing and drafting. I hope it is clear for everyone. Now coming to the next point, which is very, very important. Now introduction. So first coming to the introduction of the electrical power system. You already know you have spent 4 years or more than 4 years in universities or colleges for your engineering. You already know everything. Now I'm just giving you overview and just refreshing your engineering part. Now first coming to the power system, we are distributing the complete power system in four different stages. You already know why we are generating power. We are generating power to utilize that. Where that generated power will be utilized by that power will be utilized by my loads. Loads means, let's suppose I am having a fan. So this fan, what is the function of this fan? What is the desired function of this fan? The desired function of this fan is this fan will rotate in this direction or in this direction which is required. So it will rotate, means mechanical energy. So it will rotate. So we have two methods. One is I will create a manual method that I in early days. So some people was used to rotate that fan, but nowadays we are in smart era or in modern era where we are not using there is not any manual method. We are using electricity is converting into mechanical energy. So this fan will rotate. So to rotate this fan, I need electricity. So first electricity, if I need electricity, so first it should be generated. So it will generate in generating station. So and also you already know generating stations are not very near to my home or every home. It create it Okay, generating stations are far away from my home. Let's suppose in general I can say 100 kilometers away from my home. 100 kilometers. So just for example, 100 kilometers away from my home, generating stations. So to transmit that electricity, generated electricity to my load or to the lighting lamp which is installed in my bedroom. So I need some more stages. The electricity which is generated, it is generating, generally it generates at 11 kV. In India, it generates 11 kV or less than 11 kV in some power plants. But generally it generates to 11 kV, but in some rare case you will find at 33 kV also. So this is the generating state, but we can't transmit that electricity generating at 11 kV up to 100 kilometer, because if we transmit up to 100 kilometer at this voltage level, what will happen? The current value will be increased. When the current value will increase, obviously the conductor size will increase, the tower size will increase, losses will increase, everything, efficiency will decrease, obviously. So to means overall the cost decrease. To decrease the cost, what we do, we step up the voltage levels and transmit that electricity. So we transmit electricity up to 765 kV. We step up the voltage and transmit the electricity up to my distribution stage. So in distribution stage, you can call it as a distribution substation. So at this stage, what you will do, you will again step down the voltage, and these substations will be located near your city or nearby your city, so that electricity will be stepped down and then distribute to the different consumers. Okay, now at the last stage, you cannot use electricity directly at 11 kV or 33 kV. Your loads, like your lighting fixture, your fans, ACs, general, your loads are operate at 400 volts for three phase and 230 volts for single phase. So this will be your utilization stage. So in utilization stage, what we do, we use electricity which was generated 100 kilometer away from me. So these are the different four levels of electricity power systems, but we'll discuss only this part, the utilization, how to utilize that electricity. Like for example, let's suppose if this is your building, a high-rise building, or you can say this is your mall, shopping mall. So in this is your mall, and the total connected load of your load, which is TCL value, it is about 1 megawatt. 1 megawatt, or you can say demand load is maximum MDL, maximum demand load is 0.7 megawatt. So what you will do, you will sanction or you will apply for the electricity connection to your electrical company, electricity company, or electricity board. So what they will do, they will give you the connection at a single point. At this single point, they will give you 0.7 megawatt of electricity. Now, you have to distribute this electricity as per your requirement, as per your load in this building. So, as an electrical engineer, my responsibility will be to distribute this much amount of electricity into my this building. Okay. Now coming for role of LV system, fine, it is a final state delivering power to consumers, as I told you. And in my consumers, you can take commercial buildings, which may be your hotels, which may be your high-rise residential buildings, or you can take hospitals or universities, colleges, public buildings, means your government buildings, industrial machinery, street lighting. So these are the low voltage system, and we'll discuss about these building designing in this course. Now, this is very important for you. Uh, as per our designing, we consider safety. This is our priority. Safety, reliability, and efficiency. These are the most important. We cannot compromise first the safety, reliability, and efficiency. After that, cost and compliance with standards. With standards, like you can say IEC, IEEE, NEC, NFP, anything, any other also, or you can say IS, Indian standard. So as per your requirement, you should be compliance with your standards, your whether it is your local standards or your international standards. Okay. So now coming to, if you have any query related to this point, so please unmute your mic or please tell me.
Hello.
Yes, please.
Yes, just wanted to clarify the generation of electricity takes place at only 11 and 33 kV.
No, no, no. Mostly in India, electricity is generating up to 11 kV or less than 11 kV. In Dehradun, I am located in Dehradun. In Dehradun, we have one power plant or generating station where electricity is generating about 600 kV, 600 volts. So mostly it generates up to 11 kV, but in many rare case, mm, in my in some days back, some people, one of my friend told me in one power system there is electricity is generating at 33 kV, but it is very rare case. Generally, it generates at 11 kV. Okay, now
Okay, now
coming to the
coming
next
to the
point,
next
which is
point, which is the
responsibilities of the
responsibilities of
electric.
the
Could you please
please
mute your mic?
mute your mic.
Now, coming to
Now
the
coming to the
responsibilities of the engineers,
responsibilities.
responsibilities of the electrical engineers. So, as I told you, we are not a calculator. Oh, my voice is. So electrical design is not just about calculations to make some plus, minus, multiplication, division. It's about understanding the project's needs. Means you should know the requirement of the client. Means you what is that building and for what purpose this building will be used. So like that, you should know the project following standards, and you are responsible for the safety at every stage, not only one point. Every stage, safety should not be compromised. Okay, now first coming to the first point. So first is you should collect load requirements from clients or architects. Let's as an electrical design engineer, you will be involved in that building from first day. From the budgeting stage, you will be with the team. You will work with them in the budget stage also. So first you should collect the data from the client. Means what is this building like, whether it is hospital, whether it is your hotel, whether it is your residential building. Because after knowing this type of building, you will get idea. Let's suppose if this is this is a hospital, then there will be some medical machines will be used, like CT scan machine will be there, your x-rays machine will be there. So by keeping that in your mind, you will decide your cable size, you will decide your protective devices, and you will decide your demand factor. So based on this, you will get many information in your mind. So first collect all data from the client and your architect. Second thing, coming to interpret applicable standards and codes, like follow the local or your international codes, like IEEE, IEC, NEC, or if you are working in your specific country or a specific province or state, like as I am working in India, so I have to follow Indian standards, IS or BIS, Bureau of Indian Standards. So I have to come. I have to compliance with the codes, because by compliance with the codes, there will be two reasons. The first is the system will be safe and safe for use. System will be safe because these codes and standards are defined by many experiments from the groups that are defining these codes. And also, you will be legally approved to use that building. Okay, so this is very important as per IEC. Let's suppose if you are working on IEC codes, so as per IEC, the voltage drop should not be less greater than or equal greater than 3%. So you cannot take the value more than 3% because as per if you are working as per IEC, so you should comply with that. Now, after this codes and standards, coordinate with other trades. Like you are not only the engineer or you are not the electrical team only in the building. There will be many other services like HVAC services will be there, and plumbing services will be there. In mechanical, you can take your HVAC services, and mechanical pumps like your firefighting pumps, or plumbing pumps will be there. Your fire protection pumps will be there, and your lifts will be there, and your renewable energy NGM might also be there, as nowadays everywhere or in most of the buildings people use solar panels or some other renewable energies also. So you have to coordinate with all other teams because you have to take data. Why I am saying that? Let's suppose this is your building. In this building, you are having HVAC machines, you are having lighting fixtures, you are having your lifts, you are having your some extra low voltage services like your CCTV or your other like rodent or any other intrusion systems. So for these equipment or loads, only they need electricity. Otherwise, they are just like a dead body. HVAC system, if you will not provide electricity or supply, all these services just like a dead body. So you are responsible to supply the electrical supply to every load. So you should know about each and every load. You should collect data from the HVAC team on what type of machines you are using, and how many hours per day these machines will work, and are these machines intermittent load or continuous load, what type of load. Similarly, you should go with the lighting load. You should connect with your sustainable development department, what type of, or you should coordinate with your architect what procedure or what technology they are using to minimize the use of light in daytime. So you can use your high demand factor in daytime. So like that, you will collect all the data from other teams also, and then compile all the data in a report, and then after that you will start your calculation by keeping all these in mind. Otherwise, if you are not coordinating with these teams, you can't able to develop a safe system or appropriate or efficient system. Okay. Now, after this, ensure safety compliance means you should provide proper earthing. You should calculate proper short circuit current in your system, and use enough or effective, or you should use appropriate device protective device to protect your system from short circuit or overload condition. Okay. And then you should be responsible to prepare SLDs, layouts, schedules, BOQs. What is the meaning of schedules? I hope everyone knows. Schedule means your I'm coming on that after this slide, don't worry about that. We have two types of schedules: load schedule and panel schedules. So I'm coming on that. So you are responsible as an electrical design engineer to prepare SLD layouts, every layouts and schedules and BOQs. Then this is very important point. Let's suppose if this is your building, and right now the total connected load of this building is 100 kilowatt. But in future, some machines may also installed, or as you can see, every year we are seeing some new developments and some innovations. So some machines may also come into picture, or may some new loads may also connect in this building on this power system. So what we do, we plan for future load growth. We plan up to 20 years of future plan. We design a building or power system by keeping this in mind at least. So we'll take in between 10 to 25% spare capacity. So in future, if your client add up about 10 kilowatt or 25 kilowatt of additional load on this power system, so it can work properly. There will not any issue. So these are the some basic and fundamental responsibilities of design engineer. But these are the fundamentals. These will not be changed. But some may add it as per your client. So you should collect data from the client, compliance with the standards and codes, coordinate with your other teams, ensure safety compliance, and prepare these layouts, SLDs, schedules, and plan for future growth. I hope it is clear. Okay, please keep this mind. You are not just a calculator. You are not just calculator, just design, calculate something. But you are like the project's safety and efficiency guardian. You are guardian for safety and efficiency. Now coming to the load schedule, this is your load schedule. Load schedule, it is not a very big science. Load schedule is a document in a tabular form. You can see here, where you will find all the list of all loads in your building, like how much lighting fixtures you are having. In the complete building, you are having 100 number of lighting fixture, and each lighting fixture consume 1.5 kilowatt. Sorry, 100 kilowatts, 100 fixtures consumes 1.2 kilowatt of load. Similarly, we are having three HVAC machines which consumes 5 kilowatt. We are having this power sockets, and with the ratings, you will find some more information over here. Power, what is the power factor we are considering over here, and what is the demand factor, what is the total connected load of these loads, and what is the demand load. Do you know what is the meaning of demand load? I hope everyone knows, but let me tell you briefly. Let's suppose this is my panel, MCC panel. MCC On this MCC panel, I am having three motors, or you can say three motors are connected. Motor one, motor two. This is
Hello,
10 kilowatt.
Sadiq.
Yes, please.
Hello.
Yeah.
Uh, just to sorry to interrupt. Like, are you sharing the screen? Actually, do you have any slides? We can't see anything.
Uh, uh, you're not able to see my screen.
Yeah.
Oh.
Actually, last through your conversation, I just understand that you have some slides, but we can see anything.
Ah,
Yeah.
sorry, really,
Yeah.
really sorry. Now, are you able to see my screen now?
Yeah. Yeah. Perfect. Okay.
Oh, really, it was
Okay.
embarrassing for me. Thank you, thank you. Let me take your 1 minute time. Let me show you all the slides. This is the first slide. Second, this is my contact details. I will share this PPT with you all. Don't worry about that. And this is the first
Okay. Thank
PPT,
you. Thank you.
first slide, electrical design and drafting. I was discussing over here, and here it was the introduction of electrical power systems. And after this, coming for responsibilities of the electrical designer. Now I'm on this slide. So fourth slide. Thank you, brother. Thank you. So in this table, you will find this is the load schedule, where you will find all this information. What is type of load? What type of load you are using? What is the quantity? What is the rating? What is the power factor, demand factor, connected load, and demand load? So you will find all these information in the load schedules. We'll discuss in our complete course how to create these load schedules. Don't worry about that. So let me and what is the purpose of these load schedules? It mainly helps to calculate the total connected load and demand load. It helps us to form the basis for feeder, transformer, and generator sizing, and we'll discuss in later how it helps us ensure there is no load is missed during design. Okay. Now coming to the panel schedules, unlike your load schedule, we have panel schedule for specific each and every panels. So a panel schedule is a detailed listing of all outgoing circuit from a particular panel, along with their protective devices and cable sizes. So you can see here I'm having this panel. Let I'm taking it MDB, main distribution panel, MDP, main distribution panel. So in this I am having first panel, first circuit. It is, and it is for lighting load, office lighting load. And my circuit breaker size over here, my breaker type, what type of breaker I'm using, whether it is MCB, MCCB, or if it is the MCB, then what is the type of that MCB, like whether it is C type, B type, or D type, as per the requirement, and what is the cable size I'm using for that feeder or for the circuit. Then what is the total connected load on this circuit one. This is 1.2 kilowatt, and this is power factor current. This is the line current. We'll discuss in coming slides how to calculate the load current. Then what is the phase? What is the phase? Which on which phase I am connecting this circuit one? So I am connecting on R circuit. So this is the information you can see on my panel schedules. So these are the two schedules. So as an electrical design engineer, you are responsible to create this, because this is very important after and during installation. During installation or executions, it is very important because it helps electricians install, and after the installation, after during operation, it will help him to maintain the panel. So now it is used for breaker size, cable size selection, and phase balancing. This is very important, phase balancing, because if there is a three-phase system, so if you will connect more load on on any any phase than other, so what will happen? The system will be unbalanced. So there will be many problems come into picture. So that's why it is very important to balance the system, or load balancing. So this is your panel schedules. Now, coming to the fundamental objectives of designing as per IEEE Institute of Electrical Engineer and Electronics Engineers. This is international group which defines codes and standards for electrical engineers and electronics. So now, what are the fundamental objectives of designing? It is safety for humans and property. So, as an electrical design engineer, you will keep into mind that there should not be any electric shock from the system to any person, whether it is your building occupants, or whether it is your operator, system operator. And you should avoid any fire hazards. You should use proper equipment, or appropriate equipment for your system. Then functionality means proper voltage should be maintained. There should not be a voltage drop, or there should not be a voltage dip in your system, and you are providing, or you are getting proper or enough supply on at all points of the system. Then reliability, there should not be any power cut, or if there is any power cut, but that should be resumed within a some second by your backup power supply like DG. So this is very important, reliability. Then coming for efficiency, nowadays, let me tell you, we are every government, not only Indian government, but the world is working for 2050. 2050 is the mission of every government. It was it was, let me tell you where it was published. It was published by IIT Shastra, IIT Madras. So it was yeah, it was published by IIT Madras that visioners and planners are working on 2050 plan. Means the electricity which is generating nowadays, it is about 70% by conventional resources. Now it will be replaced by renewable energy. By 2050, every government are considering or planning to reduce the 70% about 25 to 30% only. So this is very important because and also in this plan planners are taking into picture it is efficiency, to improve the efficiency. So it is very important nowadays. If I talk about 50 years back, so there was not this concept of efficiency, or 20 years back. So nowadays we are taking into consideration efficiency, reduce energy losses, then economy. This is also another factor, and the flexibility, that you can use the same system after 10 years or 20 years by add some more additional load. So these are the fundamental objectives of designing: safety, functionality, reliability, efficiency, economic, and flexibility. But this safety and reliability are the most important. We can't compromise with these. We can't compromise with these two. After that, we'll come for efficiency, economy, and flexibility. Now, these are the objectives. Now, I am coming for the fundamental factors. There are basic difference. These are the objectives. Now, coming for the fundamental factors of designing. So, when you will design your system or start your designing the system, you should keep in mind that what is the environment where your system installed. Let's suppose if I am having a building in India, I am having another building in Africa, I am having another building in Europe. Okay. Now you can see here in India, there is a temperature in summertime, it is about to 45 degrees Celsius, or in winter, it is about 5 degrees Celsius or 10 degrees Celsius. But in Africa, hot temperature is more like about 55 degrees Celsius. But in Europe, there will be in minus 3 degree, let's suppose. So you can see here, I can't use the same cable or same equipment in India, in Africa, in Europe. I can't use the same calculation, just plus and minus. I have to keep in mind what is the temperature, what is the humidity. So by keeping these things in my mind, temperature factor, I will decide my equipment. Which equipment will be selected means, if I am selecting my cable, so which insulated cable, insulation material will be used, whether it will be PVC, XLPE, which insulation I will use. If I will use PVC in Europe, so it will crack down in this cold temperature. So by keeping all these things, I will decide or select my equipment. Now coming for the next point, supply voltage. You should keep in mind whether if you are working for single phase or three phase. So based on this voltage level, you will calculate the load current or will select the equipment. Then load profile, what type of load it is. It is continuous, or whether it is intermediate load. So based on these profile, you will select the cable, then circuit breaker, your protective devices. Then after this, we are having load factor, the demand factor. Oh, I was explaining there. What is the demand factor? Okay, okay. So let's suppose I am having this MCC panel. So on this MCC panel, I am having three motors. One is motor 10 kilowatt or 10 HP motor. It is also 10 HP motor. It is my 5 HP motor. So now on this panel, if I ask you what is the total connected load, so the total connected load of this panel, you can easily tell me TCL value is 25 HP. But if I ask you what is the maximum demand load, maximum demand load means at a time how many motors or how much load will operate simultaneously. Let's suppose this is my jockey pump or fire pump. This is my fire pump. This is my another fire pump, but it is on standby. Standby. It is my another pump. You can say my uh, water pump. Water pump. So this is a fire pump which can operate or which operates. Now this is my water pump. It operates daily. Now this is my standby, standby motor. It will operate only when in case of this failure. If this motor is fails, then it will operate. So you can see here simultaneously only these two motors can operate, this one and this one, in any condition. This will not if this is operating, this will not operate. So the maximum demand load will be 15 HP. So this is my demand load. So how to calculate the demand factor? Demand factor is just in a MDL value over the TCL value. It will be your demand factor. Means you will get in percentage or in decimal value, how much percent of the total connected load can operate at at a time. So based on this, and keep this mind, we calculate cable size, we calculate circuit breaker size based on MDL value, not on TCL value. Okay, so based on this MDL value, I will calculate the size of circuit breaker or my feeder. So this is my demand factor. Now after this, voltage drop limits. So for lighting loads, the voltage drop should be less than or equals to 3% as per IEC, and for power loads, it should be less than or equals to 5%. Okay. So these are the fundamental factors. By keeping this mind, we'll start our calculation. Now, after this, coming for the nature of load, I will not discuss, or I will not spend more time here. Just let me tell you about the nature of load. So generally, we are having three types of resistive load, inductive load, capacitive load, and nowadays we are using some electronic devices to improve our efficiency and to increase the control over my machines. So we are using some non-linear devices. Like non-linear devices, you can take it as the device which contains electronic equipment that will be a non-linear. Okay, for briefly you can understand in this way. So we are having three types of load: resistive load, inductive load, capacitive load, and non-linear load. Whereas these loads are known as linear load. We'll discuss about linear load and non-linear load in detail when we'll start our in detail course. So in resistive load, what happens? This it means that, let's suppose if this is your load, you are supplying electrical energy here. So the total energy you are supplying here, the total energy, it is converting into another form. Let's suppose if this is your a heater, if this is your heater, so the total energy you are supplying. Could you please mute your mic? Please don't open the mic. So let's suppose if this is your load. So in this load, first I am considering it a resistive load. Resistive load means heater. Let's suppose if please mute your mic, please. If this is your heater, it means that the total energy which is supplied at the input terminal, the total energy will be converted into heat energy. Okay, but now coming to inductive load, what is the meaning of inductive load? Let's suppose if you are having motor, so in this motor you are supplying electrical energy at input side, but the at output, the energy which you are getting over here, the total energy will not convert into your active energy or in your at the output side. So what happen? So some energy, some of the input or supplied energy will be stored to create or magnetic flux. to, are you able to understand? The total energy which you are supplying over here, some of the energy will be stored in this motor to create magnetic flux, because without any magnetic flux your motor will not able to rotate. So to rotate that motor you need this magnetic flux. So this magnetic flux will store some energy. So that will be your inductive load. You are supplying total energy as in you can say as apparent power, but the power which is stored here it will be your reactive power. But the power which is converting into rotating power or mechanical power, that will be your active power. Okay, so this is your inductive load. Similarly the capacitive load here, but the in capacitive load the energy you will get in plus. You will get, I will discuss in detail when we'll discuss our capacitor banks or FPA, power factor correction panel. Then coming to your non-linear load, as I told you, now we are nowadays we are using some electronic equipment. So by using that equipment, we are experiencing or facing some harmonic issues. What these are the very very dangerous for our power system, because if we will not eliminate these harmonics from the system, your system will be overheated, or your system will get some overload condition, that even your system is not, in actual there is not overload, but due to harmonics it will experience some overload condition. So these are the nature of load. Now coming to the types of load in a building, as we are discussing about our utilization stage. So in any building, you'll see these some basic types of load: lighting load, HVAC load, motor load, socket loads, special loads like if there is medical building, so there will be medical equipment, fire pumps or data centers like that, and emergency and critical loads. In critical loads, what you can take, you can take it as your ELV services. So these are your types of load. But in my experience, I can say that in any building we have only three types of load. One is resistive load, one is inductive load, and another is spatial load. Spatial load means your you can include your ELV services or critical services. So most of the total connected load will be your inductive load, which includes motors, because you can see in your building there will be many number of ACs, there will be lifts, there will be many other equipment also. So motor consumes most of the total connected load power. Okay, so these are the types of load. Now I am coming for my single line diagram, then we'll start our calculations. So now you already know what is the single line diagram. Single line diagram is just a blueprint of your power system, where you can see the complete power system, from where you are getting supply and to your load, how it is flowing power, how it is distributing. As you can see, it is your source means your utility company, it is supplying electricity to you. So at your point the electricity company will give you the point up to your MDB. So you will connect this power to your MDB, or there might be your transformer also. If they are supplying you at 11 kV, so you will step down that voltage from 11 kV to 400 volt or 0.4 kV, you can say. So then after getting all the supply from here, you will distribute as per your requirement: lighting panel, power panel, HVAC panel, mechanical panel, or any other panel as per your requirement. So this is a single line diagram. You can see over here the feeder or line will be shown by single line, or you can say one line. Whereas the panels, or you can say other equipment, will be shown by some symbols. As you can see, this is your transformer symbol, or we use other symbols to mention or to show our other equipment. Okay, so you can see here purpose shows the complete power flow from source to load, and these are the some elements source from where you are getting supply, or if this is your utility or grid power, you may also have your generating power equipment like DG at your premises, so that will also be there like this. So that will also be there, and there will be sub distribution boards or your main distribution boards, and final circuits also be there. And it is very important, if you work for any consultancy, so that consultancy will tell you their equipment or symbol. They will give you the list or a symbol of equipment. But if you are working for international projects or some for government projects, you need to follow international symbols, or you can use your local symbols that are defined by your government. So keep symbols as per IEC, which indicates rating, breaker types, or cable sizes. So this is very simple. So if you have any query till now, so please tell me. Now I am coming for my calculation. I am starting my calculation where you will learn. If you have any query, please tell me. No one? Okay. So is it clear for everyone till now? Okay, thank you. Now let me start. Just give me a break. Yes, please tell me, Heather.
Hello, sir. Will you
Yes,
share the presentation with us after we finish the scores?
yes, sure. I will share.
Thank you so much.
Also, I will give you one assignment. Hmm. Okay, so now coming after this, I am coming for the load current and feeder current calculation. First, let me tell you about the load current or feeder current. What does it mean? Let's suppose if I am drawing a single line diagram, short, simple single line diagram. This is my point of supply from where I am getting supply. It is my transformer. It is my main distribution panel, and this is the bus bar of my main distribution panel. Then it is distributing electrical energy to my other sub panels. Here my sub panels, here my sub panels, here my sub panels, and here it is supplying to my load like this. Okay, so you can see here, this is my point of supply from where I'm getting supply at 11 kV. This 11 kV, at 11 kV my electricity is supplying from this point to primary side of the transformer, and this transformer is stepping down the voltage. The same power, let's suppose if I am getting 100 kilowatt of power from here at 11 kV, the same power I will get here if I am neglecting losses. So 100 kilowatt of load, 100 kilowatt of power, but at 0.4 kV. The voltage level will decrease. As the voltage level decreasing, the current level will increase, obviously. So you will find mostly in cases the size of the cable at the primary side will be less as compared to the secondary side, because the current value will be increased by the same factor as your voltage is decreased. Okay, because you already know power is directly proportional to VI. As this voltage is decreasing, by the same factor current is increasing, because this P is constant, so current value will increase. Now what is the load current? Load current or feeder current? Feeder current means the current which is flowing into this feeder, or load current means for this feeder, this panel is my load. The total load which is connected to this feeder, the current which flowing through this feeder will be my load current, or you can also call it as feeder current. I hope it is clear. So I will give you some rule of thumbs or some shortcuts. This is actually not a rule of thumb. This is shortcut. I will I will tell you how how I calculated this value. So first, how to calculate the load current. It is very important because based on this load current, your circuit breaker size will be decided, your cable size will be decided. Okay, so first you should know about this equation. In your engineering, you know about this power factor equation. V is equals to cos phi for single phase. For three phase, it will be root 3 VI cos phi. Okay, now if I have to calculate the current value, then you can use this equation. I is equals to P over root 3 into V into power factor. In our calculation, what we do, we assume power factor as 0.85. And now as I am considering three phase at 400 volts, so put these values 400 over here and 0.85 over here. So, and also the power value, it is 1 kilowatt, which is means 1000. So just divide this value, you will get 1.5 amperes. Okay, and for three phase 1.7, and for single phase to do the same calculation, you will get 5.1. Now let's suppose I'm taking an example. Let's suppose this is my panel. I am having this 10 kilowatt of load of three phase. This is my three phase load of 10 kilowatt. Now what will be the load current in this feeder or feeder current? Just the feeder current, load current will be close to, as this is three phase, just three phase, then 1.7 into how much load? It is 10 kilowatt. Just multiply 10. So you will get 17 amperes approximate value. This is the shortcut. This is the load current value, 17 amperes. Now, if this is my single phase load means suppose it is 2 kilowatt of load of single phase. So how much current will flow through this line? So the current will flow for a single phase 5.1, and some people take 5.4 also, because here I am taking 230 volts over here, but some many people take it as 220 volts. So you will get 5.4 value like that. Okay, so don't worry, don't confuse with that. So 5.1 into 2, it will equal to 10.2 amperes. So the current value will increase. The current value will be 10.2 amperes. Now here it is 17 amperes. Now can you compare? For 10 kilowatt of load, it is 17 amperes of current. For 2 kilowatt of load, it is only 10.2 amperes. Yes, yes, please tell me. Yes, please tell me who raised hand. No, here it is my question. Please answer my question if you are not having any question. So you can see here for three phase, I am having volt current value 17 points for 10 kilowatt of load. But for 2 kilowatt of load, I am getting 10 amperes of current. So for this, for small load, it is 10.2. For 10 kilowatt of load, it is 17 amperes. How it is? Anyone, please?
Yes, I think for single phase where
Uh,
Yes, please.
where
Hello, you want to
using
answer?
the
Yes, yes, yeah.
okay,
I want
okay,
answer from your
yes,
side.
Because it's three phase and the formula for the three phase is root 3 multiplied by line voltage, line current times the power factor.
Okay. Uh, Anyone else? Thank you, Michael.
Yes. The current
Yes.
is inversely proportional to the voltage.
No, no. I'm saying that let me take another example. It might confuse you. Let's suppose if I am having a this is my this was my single phase, and now the same load. I am taking the same load, 2 kilowatt of load, but it is three phase. What will be the line current here? So I 1.7 into 3, it will be about 21 to 5.1 amperes. Now you can see here 5.1 amperes. This is my single phase load. This is my three phase load. Both are 2 kilowatt of load. Both are 2 kilowatt. But here line current is 5.1. Here it is 2.1. 10.2. Everyone is I think. Okay, let me tell you. Yeah, please share slides. Okay. Okay, please check. Okay, so let me tell you, the in single phase you are having two lines. One is live wire or line wire, one is neutral.
Neutral.
So here it is 2 kilowatt of load. So total current which will be required, so total current will flow through this line only. But in another case, we have three lines. This is neutral RYB. So 5.1 current flow through here, 5.1 here, 5.1 here. So the same current which flowing through this, but the current is distributed by between these three lines, among these three lines. So that's why. Okay. So I hope it is clear for everyone. So this is the shortcut how to calculate the load current. I hope it is clear for everyone. Now coming to these 2 points, these are your rule of thumb for you. Rule of thumbs. Rule of thumbs. If you are designing a small office building, so for that building you can consider lighting load per square meter 10 to 12 watts. 10 to 12 watts. Let's suppose if your client tells you I am having a building or floor area of 100 square meter. Now what will be the lighting load for that building? So you can just multiply 10 into 100. You can tell him 1 kilowatt of load. 1 kilowatt of load. 10 in is 1000 watts, which will be 1 kilowatt of load. Like this, similarly for a small apartment load, like if you are having some a small home, so for a small apartment like 2 BHK, you can take 3 to 5 kilowatt of load. Okay, but it is only a rule of thumb when you are not having complete information of the building. For just telling on fingertips, you can use these values. Okay, otherwise for complete calculation you will have to go with the proper procedure. So this is the load current or feeder current, how to calculate. Now after this I am coming for my equipment selection. Let me tell you, over here in this SLD you can see I am having cables, I am having circuit breakers. This cross sign is showing my circuit breakers, and this single line is showing my cables. Okay, and this is my transformer. So I'm coming after this, how to calculate the transformer size, how to calculate the cable size, how to calculate the transfer this circuit breaker size. Okay, and also to protect our system, what will be the main minimum size of your earthing wire in low voltage side. So after coming for my cables, in cables you can see I'm having actually two types of cable conductor. One is my copper conductor, one is my aluminum conductor. As per my you can see in low voltage, for short run we use always copper cables, but for long runs or for overhead lines we prefer this aluminum cable, aluminum cable conductor. Why? Here you can see, and it is copper. It is more conductive, but it is more costly. It is more conductive, but costly. It is and heavy weight. But it is the advantage with with your aluminum. It is cheaper as compared to your copper, and it is light weighted. Okay, but conducting capacity is less compared to your copper conductor. Clear? So let's suppose if this is your these are your rule of thumbs. How to calculate the size of cable? These are the rule of thumbs. Thumb rules. So copper, if you are using copper conductor, so for single core cable, you can, if you are installing in air, so take 6 amperes per square meter. Let's suppose if you are having a 10 square cable, so it can carry about 60 amperes of current. 1 square cable conductor is carrying 6 amperes of current, so 10 will be 60 amperes of current. So this is the rule of thumb for single core cable, but generally we use in our building multi core cable like this is multi 3 core cable. This is 5 core cable. The 5 core cable means R Y B neutral and one earthing. So this your 4 core cable. So in multi-core cable, if you are installing, whether you are installing in air or in conduit, so take 5 amperes per square I'm coming in coming slide how to calculate the size. I'm coming here. You can see I'm having a mini project. Okay, so this is your rule of thumb with respect to your copper cable. Now for aluminium conductor, the value will be decreased. For multi-core cable, it will be about 3.5 amperes per square Is it clear? Are you able to understand? Everyone clear?
Yes, I can understand. Yes.
Okay, thank you. So this is the
I
aluminium.
understand.
These are the aluminium conductors. For copper, take 5 amperes per square For aluminium, take 3.5 amperes per square And take this for voltage drop lighting, as also I mentioned in my last slide. Take for lighting load less than or equals to 3%, for power load 5%. Okay, in LV distribution system, copper is preferred for short runs and reliability. Aluminum is for cost effective long runs. Okay, so these are the rule of thumb for your cable. Now after cable, I am coming for my circuit breakers. So generally we use circuit breakers in low voltage MCB and MCCB. MCB stands for miniature circuit breaker. This is miniature circuit breaker. This is your MCCB, molded case circuit breaker. So if you are having a load current, if you are having a load current up to 125 or less than 125 amperes, so you should go with MCB. But in some cases, not every, this is not not an typical value. This is a general value. This is not mandatory to use up to 125 amperes MCB only. It is, it depends on your load, type of panel. So, okay, we will discuss in detail about where to use MCCB, where to use MCB. But as a rule of thumb, I can say that up to 125 amperes of load current, you should go with MCB, and for above current, for more current than 125, you should go with MCCB. Okay, now how to calculate the size of the circuit breaker? Just multiply 1.5, 1.25 by your full load current, means your load current, or you can say your feeder current. Just multiply, take only 25% extra, because as per NEC, it defines that you should take about 20 to 25% extra size of your conductor. Okay, this value is only for your continuous load. It will work for continuously without any nuisance tripping. For only continuous load, if you are using for intermittent load, so you should go with 1.5 value. That will be discussed in motor chapter when we will discuss our motor chapter in detail. So let's suppose if you are having this circuit, this is your circuit breaker, this is your load, and if I'm telling you the load current is 20 amperes, Then what will be the size of this circuit breaker? So 2.20 into 1.5 into 20, you will get the value 25 amperes. So the circuit breaker size of this MCB will be 25 amperes MCB, because it is less than 125 amperes. And here I mentioned over here what are the standard size that you can find easily in the market. These are the default size. You can find easily 6 amperes of circuit breaker, 10 amperes of circuit breaker, 16, 20, 25, 32, 40. So you can find, let's suppose if you are getting your value of circuit breaker around 27 amperes, so you will not find in market where it is 27 amperes of circuit breaker. So you will get 32 amperes of circuit breaker. Okay, so this is about your circuit breakers. Now coming for transformer, so you should select the size of your transformer also 25% additional by comparing your connected load or demand load. For example, if this is my POC, this is my transformer, this is my main DP, main distribution panel. The total connected load of this panel is 250 kilowatt of load. This is main demand load. Okay, not total connected load. So the what will be the size of this transformer? So transformer size 250 into 125, you will get around 315 kVA of transformer. So this will be the size of your transformer. Check in the market which is the nearby size, the default size of the transformer, and go with that and select that transformer. Okay, this is the rule of thumb to calculate the transformer size. After this, we are having a earthing. Earthing will be copper earth conductor only for LV. LV main earthing. Okay, keep it in mind, only for LV. Take minimum 16 amperes of or 16 square mm of cable, copper conductor cable. This will be directly connected to your main distribution panel. And for complete calculation, if I have this is my very large main distribution panel. So this will not be work, because we have to calculate the size of earthing properly. What will be the size of strip? What will be the how many number of pits will be there? So that is another calculation, whether there will be only one pit or there will be number of pits in a same circuit. So this is the case for only for rule of thumb. For or very small project, you can use these rule of thumb. So these are the rule of thumb. Now after this, I am coming for a small project. I'm taking. Yes, please tell me.
Sir, in some project, earthing strip also use, na sir?
Yeah, yeah,
50 by
exactly. Yeah,
25
exactly. The
meters.
same thing. The same thing I'm explaining over here. If you are having a very big project, for that big load or large load, we have to calculate proper size of earthing. What will be the size of this strip? What will be the thickness? What will be the breadth of this? What will be the breadth, and what will be the length, minimum length? How many number of bits will be there? What should be the minimum resistance? What should be the minimum resistance of this strip? Everything that will be discussed or that will be calculated in detail, but it is not possible for me to calculate or to consider everything in this only 2 hours. So that's why I'm just telling you some rule of thumb that you can use for let's suppose if your client ask you about 4 years back, what happens, one person called me from Chennai, and he asked me, could you please help me in creating a single line diagram? I asked him, I'm not having a complete information of the building. Even the client was not having complete information. He just has to meeting with the client without any information. Only information of the building was that we have 3 floors in the building, and each floor having 300 square meter area, like that. So he told me only this. So based on that value, I used these rule of thumbs and create my other SLD and share with the client. Okay. So if this is clear for everyone, please confirm. Let me let me start the project, mini project. Is anyone right over here? Anything? Please, are you going share slides? Yes, yes, yes. Yes, please. Yes, please tell me. Yes, please. Do you have any query? Okay, now I am coming for my mini project. So in this, you can see here. Now I am having a data. I am having given data from my client that floor area of the building is 500 square meter. Okay, 500 square meter. Now I know that lighting load 12 watt per square meter. Power sockets, they gave me 5 kilowatt. HVAC machines, they gave me 15 kilowatt. Lift machines 7.5 kilowatt, and power factor I have to use 0.9. So based on this value, these values, I have to create my uh, calculate the circuit breaker size, cable size, transformer size, and like this. This is circuit breaker, this circuit breaker, this is transformer. What will be the size of my transformer? I have to calculate what will be the size of my this main cable, this cable, this cable. So first I how to calculate the size, or how to decide the size of cable. First I should know the line current. What is the line current? How to calculate the line current? Before calculating the line current, I should have the load, how much load is connected on this cable. So how much load is connected here? Let me tell you. Now, first load is lighting load, which is 6 kilowatt of load. It is 6 kilowatt of load is connected. It is 5 kilowatt of load connected. Here it is 15 kilowatt of load connected. Here it is 7.5 kilowatt of load connected. Now, the total connected load on this point, at this point, will be how much it will be? Connected load, it will be 33.6 plus 5 plus 15 plus 7.5, it will be 33.5 kilowatt of load. This is my total connected load, but the cable size and circuit breaker size will be calculated based on demand factor. So how to calculate the demand factor? I am taking demand factor as 0.85. I am saying that this is the total load, but the complete load will not operate simultaneously or at the same time. Only 85% of the load can operate at the same time. So I am just multiplying 33.5 into 0.85. You will get 28.47 kilowatt of load. So this is the load. Based on this value, I will calculate or decide the size of my circuit breaker and transformer and cable. Is it clear for everyone till now?
Yes, it's clear to me.
Okay, thank you. Thank you. So after this,
Yeah.
yes, please, who have raised hand? Now coming to the load current, how to calculate the load current? As you can see, the total current which I was using, P is equals to root 3 VI cos phi. The same equation I am using here, I is equals to power value, which is 28.4 kilowatt. Now I am multiplying by 1000, so 28475 divided by root 3 into 400 voltage into 0.9, which was given value by my client, power factor 0.9. So the value is around 45.7 amperes of current. So the line current of my main feeder, 47 point something approximate, 47. Now based on this much, this will be the current that will flow through this feeder. Now what will be the size of this circuit breaker and this cable? So what I will do, I will calculate the feeder sizing. Feeder means cable including circuit breaker. So cable size will be, as you can see, I am considering 1 square mm cable. 1 square mm cable can 5 amperes of current, 5 amperes of current can carry by 1 square mm of copper conductor. Okay. Now, what will be the current value? What will be the current value? Oh, this much of amount of current will be carried by how much? What will be the size of cable? So how it will be? It will be mm, 1 upon 5 into 45.7 amperes. So approximate value that you will get, it will be 10 square mm. For example, you will get a value around 9 point something, but you will not able to find the size of cable of this size. So check the nearby size. It will be 10 square mm of cable copper conductor. So I am selecting cable of 10 square mm copper conductor. Clear? So the cable which will be used for this feeder, it will be 10 square mm copper of XLPE. Clear? Now coming to the circuit breaker. So to calculate the circuit breaker size, just multiply by 245 ampere. This will be the load current. So breaker size can be calculated 1.25 into 45 amperes. 45.7 amperes. So around you will get 63 amperes of nearby size, which is available in market. But here you can see I am using MCCB, not MCB. While I was telling you up to 125 amperes of current, you will go with your MCB. But here I am using MCCB. Why? Because this is my main panel or main feeder. So that's why I'm using MCCB. Okay. Now this is my cable size and circuit breaker size, 63 amperes of MCCB. Now coming for the transformer sizing. Yes, please.
What happen if you use MCB instead of MCCB?
Okay.
In if you consider cost, then MCB will be cheaper. Why we
Exactly,
should
exactly,
prepare
exactly.
MCCB?
Yes, exactly. Because if in future, if you add some more additional loads here, so in your MCB you can make some settings. You can make settings in MCCB, so you can use easily your additional load, but it is not provision in MCB. That's why we are using
Uh,
MCCB.
okay, I have got. Sir, in MCCB there is the provision for adjustment. No, sir.
Yes, exactly. That will
Uh,
be discussed. We'll discuss. We have a separate chapter of circuit breakers. We'll discuss in detail how to select MCCB, how to select ACB, how to select MCB, and based on what type of load we should go with, what type of MCB or MCCB. So based on that, we'll discuss, and even we'll calculate what will be the maximum level of current, fault current it can handle, that can be handled by my load protective devices. So based on everything, there is very you will learn many things in our coming course in electrical designing. You will learn very much with us if you will interest. So now coming to the transformer sizing after this. So after the transformer sizing, I can calculate just by multiply 1.25 into your demand load, which is 20.5 kilowatt. It will around 35 kVA, 35 kilowatt. Oh, sorry. It is in kilowatt, but the transformer size you will get in kVA. So how to convert in kVA? Just divide by power factor. So you can just divide by 0.85. So around you will get 28.5 kilowatt, around 35 kVA transformer. So, but this is the load, the demand load. So how to calculate the transformer size, just multiply by 1.25. So you will get around how much value? 1.25 into 35. You will get 43.75, 44 approximate, 44 kVA. But it is not available in market. Nearby size will be around 50 kVA of transformer. So this is the transformer that you can use for your building. For this will be your 50 kVA of transformer. This is the way how to calculate transformer size, cable size, load current, circuit breaker size. I hope it is clear for everyone. If you have any query related to this point, please tell me, and then after this, I will go further. Yes, please. Anyone have any query, please? Okay, so thank you. Thank you. I'm coming for my other slides. So, one more thing. Yes, please, Mr. Okay, mute. Yes, please tell me.
Okay, so I had some challenges when you were doing some initial calculations with the cable sizing and all of that. But I'm relying on this video and maybe the slides to be able to maybe help myself later. I believe that will aid me to be able to do it seamlessly later.
Sure,
Thank you.
sure. Thank you. Have a good. Yeah, one more thing, let me tell you about this. From 14th of August, we are going to start our complete course for this designing, and let me show you what you will learn there. So there we have 25 chapters for complete chapter, and these 8 chapters for drafting. In this part, what you will learn introduction of the course, obviously, then basic of electrical course and standards, what codes and standards we should use in what field, and for specific needs which codes we should use. Then what are the how to calculate the lighting fixtures in your project, and what how to select circuit breakers, then capacitor banks, lighting designing, load scheduling, yeah, and panel scheduling will also be there. Electrical motors, electrical transformer, DGs, UPS, power cables, and short circuit calculation, voltage drop calculation. These are the very important calculations. Then cable tray size calculation, earthing calculation, special circuit design, bus bars, harmonics, voltage level consideration, lightning arresters, coordination of design, that I discussed with you in starting, and also dialects chapter. Dialects means, you can see here, this is a software which is used to calculate the lighting fixture. You can see it is created by me on this dialect software. You can see here, and here I created this scene. Painted walls. I put it down the sofa, almirah, and these shelves. I created this false ceiling. Then these lights are switched on. You can see here how this room will look in night when these lighting fixture will be switched on. There's a simulator software I modeled, and I simulated. So you can see here how it will looks. So you will learn here. And also in drafting part, you will learn what is the meaning of drafting, how to start drafting, how to create legends in drawing. Some means, you can see this is my single line diagram. In single line diagram, I am using these symbols, how to create these legends. These symbols are known as legends. So how to create legends in in my AutoCAD. Then how to create single line diagram, lighting layouts, power outlets, conduit layouts, electrical wiring, CCTV design, plus drafting. So you will learn all these things in this course. And also, our institute is offering a good, very big discount on enrolling today. Generally, we charge about 300 USD for this course, or for if I talk in Indian rupees, we charge 18,000 Indian rupees. But if you enroll today or tomorrow with our team, so you will get a exciting offer. So if you are interested, so you can join this batch. Now after this I am giving you an assignment. So this is an assignment. You are having two-story building, office building. So for this I am you are having total rated load 80 kilowatt power supply I am giving here. Last time I was using 400 kilowatt volts, but here I am changing some values. So supply voltage will be 415 volts, three phase, 50 hertz, and demand factor you should use zero point 0.6 in this case. Then main distribution board is located on ground floor, other panels on each floor. Then you are having lighting load, socket load, HVAC, and office equipment. So use these information and create a simple power system, or create a single line diagram, calculate equipment size, and share with me in the group. So you will get response from my side. Now it's complete from my side. If you have any query, please start your query. Thank you.